Hello guys, welcome to Head First Design Pattern video series. In this we will cover all the chapters from the book. This is the first video in this series, so we are starting with our first chapter, Introduction to Design Patterns. So let's start. So we have a Joy who is working for a company which creates a SIMU duck application. These applications offer three functionalities: Quake, Swim, and Display. The duck class is the superclass who basically take care of Quake and Swim behavior. The display method is an abstract method since all the duck subtype looks different. The child classes of duck or the subtypes should implement this display method as all the subtypes looks different. Things were good so far, but management wants to add a new behavior, fly behavior. So they asked Joy to implement this new fly behavior. So this is what Joy has done. He added a new fly method in the parent duck class. So all the subtypes who are inheriting the duck class now automatically gets this new behavior without modifying any code. Impressive, right? But something went wrong. Joy got a call from his colleague saying she was having a demo with the client and there were few rubber ducks flying over the display. She asked, "Was that your joke, Joy?" So, what went wrong in this design? So, Joy was not able to figure out there are other ducks who doesn't supposed to have this behavior. Once he added this fly behavior in the super duck class, all the subtypes gave the flying ability, even though that the one which should not be flying. So Joy saw this rubber duck and he saw he is overwriting the quick method in this rubber duck class. So he come up with the idea like he can do the same for fly method. He can override the fly method in the rubber duck class to solve this issue. So this is what he has done. He overrided the fly method in the rubber duck class. But once he done this, he got some input saying the management was looking to add a wooden decoy that doesn't supposed to fly or quake. So if that's the case, then Joy end up having more code changes where he keeps on overriding the parent class method in the child duck classes. So what could be the better design he think of? He come up with an idea of extracting out the fly and quake behavior from the duck class. So he created a flyable and quakeable interface with the fly and quake method in it. Now the duck class has only two methods, swim and display. The duck who should fly should implement the flyable interface, and the duck who wants to quake should implement the quakeable interface. So with this he was able to handle a scenario. What do you think about this design? Please write in the comment. So with this we landed up upon our very first design principle, which says Identify the aspect of your application that varies and separate them from what stays the same. By this, you can see the duck class was having fly and quick behavior, which was changing every single time. So we have extracted out this flyable and quick behavior from our duck class. The duck class is still the super class of all the ducks, but without fly and quick behavior in it. The fly behavior and quick behavior is now handled under the fly behavior and quick behavior interface. The second design principle says program to an interface, not not an implementation. So what basically it says, like, once we have our flyable interface, we can provide an implementations to it, fly with wings or no fly. So the ducks who wants to fly will have a fly with wings capability, and the ducks who doesn't want to fly can use fly no way functionality. So let's extend this for the quackable too. Here you can see the flyable behavior is an interface that all flying classes implement. All new flying classes just need to implement the fly method. This is the implementation of flying for all ducks that have wings under fly with wings. And here is the implementation of all the ducks that can't fly under fly no wing. Similar to this, you can see the quick behavior. The same things here for the quick behavior. We have an interface that just include the quick method that needs to be implemented. The quick subtype basically provides an implementation for the ducks who basically quacks. And similar to this, we have squeak and mute quack. With this design, the other types of object can reuse the fly and quick behavior because behaviors are no longer hidden away in our duck class. And we added a new behavior without modifying any of our existing behavior class or touching any duck class that uses the behavior. Now let's integrate what we have learned so far to our original duck class. The behavior are declared as the behavior variables are declared as the behavior interface type, and we added this perform quack and perform fly method, which basically use the fly behavior and makes a call to fly method. Similar to this, we have perform quick, which uses the quick behavior reference to call the quick quack method from the provided behavior. So here is a big picture. We have extracted out the fly behavior and quick behavior with the reference or composition called fly behavior and quick behavior. So what basically we are getting by having a composition over an interface is that at any point in time we can add a new or provide a new fly behavior to our duck class via setter and getter method. So with this, we come to our third design principle, which says favor composition over inheritance. So as we have discussed, is like composition lets you change the behavior at the runtime as long as the object you are composing with implements the correct interface behavior. Okay, congratulations. So we have learned the strategy design pattern. Strategy design patterns define the family of an algorithms, encapsulates each one and makes them interchangeable. A strategy lets the algorithm vary independently from the client. Hope you find this video helpful. Thanks for watching. Please like, share and subscribe to support